morning, folks. I'm Farrell from Apex Solar, and we wanted to bring you the second part in our two-part series on wind turbines. This is a video, the first video we did, you'll find on YouTube and our website, and it talks a little bit about the installation of the tower. And the second part, which we're going to talk a little bit more about the turbine in depth. And we decided to bring to you today a new product that we've discovered. We're very excited about it. So this is the Zephyr Airdolphin, and this particular one is a GTO model, and it's got a 1.1 kW rating. So when we open up the box, some of the components inside the main box is obviously the turbine itself. This is the generator, and as you can see, its size is not too big. It's 19.5 kilograms, which means it has a very low weight for the amount of output. This is especially good because the tower strength doesn't have to be quite as strong for the size of the turbine output, and it's a little more responsive on the tower to changing winds because of the mass of the weight in the turbine itself. It can move and turn a lot more quickly. Okay, so I wanted to discuss a little bit about some of the different options that the Zephyr model comes in. This particular one is a GTO model. It's a 250 volt DC output. They also, and this is basically made to be grid connected. It would work through an inverter to produce 240 volts AC power at 60 hertz. The other models that are available are for battery-based systems, and they work with either 24 or 48 volt battery systems. Because this is the GTO model and it is grid tied, it will work in conjunction with an inverter to take the DC output of this and turn it into AC power. So next I wanted to talk a little bit about the rotors on this turbine, and also the power output of this turbine. Like I mentioned earlier, it's a 1.1 kW output, and that's at 12.5 meters per second. But unlike most of the turbines that we've seen in the past that limit the speed and the output of the turbine because of mostly, I think, because of destruction of the turbine at higher speeds, this turbine is designed and is capable of continuing to put out power at much higher wind speeds. As the speed continues up to 20 meters per second, the turbine can put out up to 4,000 watts of output power. This is a really nice feature that we especially liked, because you're not limiting the output power based on wind speed. Most turbines we've seen go into a furl or shutdown mode as the wind speed goes up. This particular turbine here has a survival speed of 65 meters per second, which is very, very high. So part of that is due into the low mass of the turbine blades. These are carbon fiber blades with a foam core, and they're very light and very, very strong. Some of the features about the blade that we really liked was not only the design is very high-tech, pulling as much power out of that wind as possible, but also it has these noise reducing ridges along it, and the ridges are taken from kind of the animal kingdom. Owls use the same kind of noise reducing feature in catching their prey, and what this does on this particular blade is it allows the blade to operate obviously a lot more quiet than some of the other turbine blades we've seen. One of the other features that we really liked about the blade is the blade is completely sealed in the carbon fiber skin. Now, why is that important? Basically, a lot of the blades that we've seen in the past on other turbines have holes drilled in them where you would attach the blade to the hub. This particular setup is different, and that the blade has a unique shape at the end, and that shape fits into a pocket in the hub. That allows the blade to actually be attached to the hub with no bolts and no penetrations of the skin. This is especially nice because it allows this to remain sealed. Water and moisture cannot get inside the blade and cause imbalance. And that's one of the biggest things that we've seen with some of the other manufacturers, is over time the blades would get waterlogged, and as a result they'd have to be replaced, and they'd also delaminate the blades. So we're very interested in this particular innovation that they came up with, and we'll see how that plays out. The other thing is each blade has a serial number embossed on it, and the hub has a serial number embossed on it. So what that means is that they've actually done a weight on each blade. You can see a little bit of weight fill here, and so the blade and the hub are completely balanced, and so you don't need to worry about having to do that. And when it gets up there, it's going to spin very smoothly and quietly. So again, another nice little feature. Okay, so we've mounted our turbine on our 105-foot tower, and let's get it up in the air. Hey folks, we'd like to invite you to visit the website. We are going to be providing some performance data and our take on how this new turbine is doing on our newsletter, which is available at our website. Come and visit us.